So this is 5.8B as in boy, college algebra, page 513. This is example 2. And what we're doing is looking again at partial fraction decompositions. And notice the degree of the numerator of this here is 2, and the degree of the denominator down here is 3. So remember, this here has a 1, this has a squared. If we multiplied this out, x minus 2 times x minus 2, multiplied it by 2x minus 1, we'd end up getting the degree of this denominator being a 3. Or you could do something as simple as know that this is a 1, and 1 plus 2 is going to give you a 3. So because the numerator degree is smaller than the denominator, we follow the same method we did in example 1, the last one we did. So what we're going to do is we're going to make this problem here equal to 3 different fractions. Because the highest degree, the degree of the denominator is a 3, there's going to be 3 parts to this. So we're going to have our first part, a over 2x minus 1. And this is where it gets a little tricky. B over x minus 2, and there's nothing on there, just an x minus 2, plus c over x minus 2 squared. Alright, this is the way it will always be. If we have an exponent up here on a parenthesis, on a linear factor here, if it's made nonlinear with the squared up here, we're going to divide it up into its linear part, just x minus 2, and then its squared part, x minus 2, the quantity squared. If this had a 3 on it, it would be x minus 2 squared, x minus 2 cubed. Okay? And I did some research to find out why, and I cannot remember, and I do not know any reason why. I looked in calculus books and did some searches. Can't give you a good reason why that's true. Just remember that it is true. So it's going to look like that. X minus 2 with a 1, x minus 2 with a 2. Okay, so given that information, now we're going to go ahead and put this whole, each of these partial fractions as one whole fraction by common denominators again. So we're going to just kind of realize that this this left-hand side is just going to drag down with us and follow us along, but we're going to change all of this here to one fraction instead of 2. So that means we have to find common denominators. So again, I'm going to make this a little bit bigger because we're going to have a lot more here. I've got a 2x minus 1, and what am I missing there? I'm missing the x minus 2 squared. So if I put an x minus 2, the quantity squared, that is also meaning that I'm getting that one too. So I'm just looking for this one here and putting that over here, because when I do that, since this is only 1, it's assumed to be over there as well. Okay, so then I've got an x minus 2, the quantity squared, up there. And then I've got a b. And what am I missing there? I'm missing a 2x minus 1. And so I've got a 2x minus 1 there. And I'm also missing, I've got one x minus 2, but this one says there's 2 of them, so I need to have a second one on there. So I could write it twice for the one here and then for the one I'm missing here, but let's just write it once by putting a squared sign on that. And then I've got to write my x minus 2 here. Alright, plus c over, and I'm missing this 2x minus 1, and I've already got my x minus 2, the quantity squared, so I've got a 2x minus 1. Okay, well, let's get rid of the denominators. Put this thing here right back on our problem. So we have 7x squared minus 29x plus 24. equals A times x minus 2, the quantity squared, plus my b plus my c, and I don't need a denominator. My denominators go away. All right, so now is where I look at my A and my B and my C, and I have to make that determination of what do I need that's going to make this 0, but if I make this 0, I still have a B and a C that do not cancel out. I have one equation, but I still have a B and a C. Okay, so what I'm going to do is I'm going to look here and see which term is in two of these, so it'll end up canceling two variables instead of just one. So I've got a 2x minus 1 here and a 2x minus 1 here. So if I can make this 0 and this 0, my b's and c's go away and I'm just finding the a. So that's what you want to do, and I'm assuming that that was the reason why this was x minus 2 and this is x minus 2 squared, is so that this 2x minus 1 would show up in both places here and be able to get rid of your b and your c at the same time, leaving you with just an a. So hopefully that makes sense what I'm saying there. So I'm going to find out 2x minus 1, set that equal to 0, and find out what x has to be in order to make this 0. Alright, so when I do that, I find out it's 1/2. So if I put 1/2 in here and 1/2 in here, I'm just going to say those will go away. So then I'm left with 7 times 1/2 squared minus 29 times 1/2 plus 24 equals a times 1/2 minus 2, the quantity squared, because my a or my b and my c disappeared. All right, so at this point I will let you do the simple math here of figuring this out, and when you do that, you'll find out that you get 45 over 4 when you go through all the math and square the 1/2, multiply 1/2 times 29, subtract, do all that stuff. And over here, you're going to get 1/2 minus 2, which is going to be negative 3/2 squared, which is going to be 9/4 a. And then when you divide both sides by 9 over 4 and invert and multiply, you're going to get an a value of 5. Okay, so we found our a. Our a value is 5. So let me clean this up and get us back to where we originally were so we can see what that looks like. So here we are at our original problem, and this a here will be replaced with the number 5. Okay, so now what we're going to do is we're going to look for our b and our c. Okay, so remember in the last one we needed to get rid of two variables. So I put a number in here for this and a number in here for this, and I erased all of those. Okay, we have an x minus 2 and an x minus 2 here, an a and b. So if I put a 2 in for here, that would make that disappear. If I put a 2 in for that, that would make that a 0 times that is 0 times that is 0. So it would zero both of these out and allow me to find c. So that'll be my next step. I'm going to put a, what did I say, a 2 in here. Okay, and I know that's going to go away and that's going to go away. So I'm not even going to put those on there. Okay, so this gives me 28 minus 58 plus 24 equals 3c. Do the math there, and you get negative 6 equals 3c. Doesn't look like a 3, doesn't look like an equal. Divide both sides by 3, and I get c equals negative 2. So then that can go up there. Okay, so we found a, and we found c. So we know a is 5, and we know c is negative 2. So what we're going to do is we're going to replace my a here with 5 and my c here with negative 2. So it will look like, well, if we just get rid of our a, and instead of an a there, we put in our 5. And for our c, we're going to put in what we found to c to be equal, which was negative 2. Just put that right over the top there. Alright, so one of the things that you'll notice is we're looking for b. Well, if I put 1/2 in for x, that's going to zero my b out, make it go away, and I don't want it to go away. I want these to go away. Well, really I don't, because I found a and c, so my variables are kind of gone. I can't put 2 in here either, because that'll make this b go away. So I need to put in a number here for x that will keep the b, but will make it easy for me to solve this whole thing. And I can put any number I want in here for x. Does not matter. So what I'm going to do is I'm going to pick a number that's going to be a little bit easier. So I'm going to put 1 in for x, because that'll just make it easier all the way across the board. So notice it made life easier there. It makes this a negative 1. And that'll be a b. And that'll be 2 times 1 minus 1, which is 1. 1 minus 2 is negative 1, plus negative 2 times 1 is 2, minus 1 is 1. So see how it made it a lot easier? So we have 7 minus 29 plus 24 equals 5 plus b times negative 1 minus 2. Okay, so now we have 2 equals, that's what that gives me, 5 minus b minus 2, which gives me a b value of 1. So now my b value, clear up here at the top in the very beginning, is going to be 1. So my answer for this whole thing, doing partial fractions, is going to be 5 over 2x minus 1 plus 1 over x minus 2 plus, or I guess I should say, minus 2 over x minus 2, the quantity squared. So that's my answer. That's my decomposition.